This is part 5 of the series Quadrilaterals, and in this part we're going to begin by continuing to practice some of the properties of parallelograms. In this case, we're practicing the properties with diagonals. So it says, for what value of x is quadrilateral CDEF a parallelogram? In order for this to be a parallelogram, these diagonals have to bisect each other, which means that this piece has to be equal to this piece. So that's what we're going to start off with. So our equation is 5x minus 8 equals 3x. Let's go ahead and subtract the 3x. 2x minus 8 equals 0. Add the 8. 2x equals 8. Divide by 2. X equals 4. Therefore, x has to be 4 for this side to be congruent to this side, and therefore these diagonals bisect each other, and therefore this is a parallelogram. So let's go on to another example. Here we have a slightly more complicated example. It just has two expressions, and we're not using the diagonals in this case. Here we're using the property of opposite congruent angles. So in order for this to be a parallelogram, these opposite angles have to be congruent. So this equals this. Let's go ahead and write that. 3x minus 32 equals 2x. Subtract the 2x. X minus 32 equals 0. Add the 32. X equals 32. Now we're going to have to do the same for the y's. So this has to equal this. So 4y equals y plus 87. Subtract the y. 3y equals 87. Divide by 3, and y equals 29. Now we can cross-check this if we wanted to. We can plug this value into here, so this angle becomes 64 degrees. And if we put this into here, 4 times 29 is 116. 116 plus 64 is going to be 180. And that's what's required because these two angles are going to have to be consecutive angles. So we've got the right values. X is 32, y is 29. And let's do one more example here. In this example, we want to show that this quadrilateral is a parallelogram. Now the easiest way to do this is to use slope. Go right to the heart of the issue and show that this side is parallel to this side and this side is parallel to this side. Let's begin. The slope of AD is the difference of the y's, 3 minus 0, over the difference of the x's, negative 3 minus 0, which is 3 over negative 3, which is negative 1. Let's find the slope of BC now. That's 5 minus 2 over 2 minus 5. That's 3 over negative 3, which again is negative 1. BC is parallel to AD. Now let's do AB. Slope of AB, 3 minus 5 over negative 3 minus 2. 3 minus 5 is negative 2. Negative 3 minus 2 is negative 5. So this is 2/5. And now DC. That is 0 minus 2. That's the difference of the y's. Over 0 minus 5, which is negative 2 over negative 5 and 2/5. We can see now that these are parallel and these are parallel. You could have done the same thing by calculating it, by counting, but I like to use these formulas for the instances when we can't count and they give us decimal values it's always good to have a good handle on the slope formula. All right, let's move on to the next section. Before we move on to the next type of quadrilateral, since we've only covered one type, parallelograms, I thought it would be appropriate at this point to talk about where we're going and show that there is a relationship between all these quadrilaterals. So this is a quadrilateral tree that I drew here, and it represents a hierarchy. What you can take away from this picture is that everything in a level below inherits the properties of the object above it. So a parallelogram is a quadrilateral. It inherits all the properties of a quadrilateral. And therefore, a rectangle and a rhombus are both parallelograms. So they're going to inherit all the properties we've talked about regarding parallelograms. And as we go through the tree, that's going to be the same for each one of these branches of the tree. The things that are in gray are the things we haven't covered yet. Things in white are things we have covered. So we'll revisit this tree and fill it in as we move along in our discussion. In this section, we're moving down one level in our hierarchy of quadrilaterals, and we're going one more level detailed. These are all parallelograms. They are rhombi, rectangles, and squares. And before we move on, just a quick note. Some publishers alter the plural form of rhombi, and I am not in agreement with that alteration. So this is the way I'm going to refer to the plural of rhombus. So one rhombus, many rhombi. All right. A rhombus is a parallelogram with four congruent sides. So it inherits all the properties of a parallelogram, that of bisecting diagonals, opposite congruent angles, and you can see here these also have opposite congruent sides. So all the properties that we've talked about regarding parallelograms exist in a rhombus. The same is true for rectangles. A rectangle is a parallelogram with four right angles. It also has four congruent angles. If you know that a quadrilateral, the sum of the measures of the angles of a quadrilateral add up to 360 degrees, then they would all be 90-degree angles, so they're all congruent. But the formal form is four right angles. This is a parallelogram, therefore opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. All the properties that we talked about are true with rectangles. If we remember back to the picture, squares were at the level below a rhombus and a rectangle, which means that a square inherits all the properties of both rhombi and rectangles. So a parallelogram with four congruent sides and four right angles is the definition of a square, but a square is also both a rhombus and a rectangle. That's going to come in handy in many problems when you're trying to distinguish the two. So a square is a rectangle, but a rectangle doesn't necessarily have to be a square. A square is a rhombus, but a rhombus doesn't necessarily have to be a square. So that distinction is going to become clear as we go through the rest of these details. So now let's take a look at the properties of these three shapes that distinguish them from an ordinary parallelogram. The first thing we're going to look at are three corollaries that help us distinguish between quadrilaterals and rhombi, rectangles, and squares. The rhombus corollary says that a quadrilateral is a rhombus if and only if it has four congruent sides. This is a biconditional, so it's conditional and its converse are both true. If a quadrilateral has four congruent sides, we can see that this is a parallelogram, and that's from the parallelogram opposite sides converse theorem. And because it's a parallelogram that has four congruent sides, we know it's a rhombus from the definition of a rhombus. So that corollary is a fairly straightforward corollary. For the rectangle corollary, a quadrilateral is a rectangle if and only if it has 4 right angles. Here we have a quadrilateral with 4 right angles. This has to be a parallelogram because it's a quadrilateral with opposite congruent sides. And so this must be a parallelogram, and it's a parallelogram with 4 right angles. So again, by the definition of a rectangle, this is a rectangle. So these corollaries are fairly straightforward. And as we stated earlier, the square corollary, a quadrilateral is a square if and only if it is a rhombus and a rectangle, because a square inherits all the properties of rhombi and rectangles. We know that this must be a parallelogram, and it's a parallelogram with 4 right angles and 4 congruent sides. So by the definition of a square, it's a square. So these corollaries are fairly straightforward, but we're going to need them. They're a very vital part of showing that quadrilaterals are in fact rhombi or rectangles or squares. So let's move on to the next property. Here we have the rhombus diagonals theorem, and it says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So this is a biconditional, and because of that, you can split this into 2 separate statements. You can say that if a parallelogram is a rhombus, then its diagonals are perpendicular, and you can say that if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So we're going to go ahead and prove one of these 2 parts just to show a proof of this theorem. The part of the theorem I'm going to prove is ABCD is a parallelogram and AC is perpendicular to BD. So the diagonals are perpendicular. So we have a parallelogram with perpendicular diagonals. The plan here is to show that these 2 triangles are congruent, and therefore these 2 sides are congruent. And since this is a parallelogram, this side is congruent to this side to this, and since all 4 sides are going to be congruent, we can show that this is a rhombus. So that's our general plan. So here's the given. We have angle AXB and angle CXB are right angles. So AXB, CXB are right angles, and therefore those angles are congruent. So AXB is congruent to CXB by the right angle congruence theorem. We know that AX is congruent to XC, so this is congruent to this, and that's by the parallelogram bisecting diagonals theorem. We know that BX is congruent to itself, so this is congruent to itself by the reflexive property of segment congruence. And therefore the 2 triangles are congruent. Triangle ABX is congruent to triangle CBX by side angle side congruence theorem. Now, since these 2 triangles are congruent, we know that this side is congruent to this side by CPCTC, corresponding parts of congruent triangles are congruent. Then we know that AB is congruent to CD, so AB is congruent to CD, and BC is congruent to AD by the parallelogram opposite sides theorem. We know that this is a parallelogram, so these 2 sides and these 2 sides have to be congruent. Therefore, AB is congruent to BC, is congruent to CD, is congruent to AD by the transitive property of segment congruence. So all these segments are congruent. Now, since we were given that this is a parallelogram, and we've just proven that it's a parallelogram with 4 congruent sides, ABCD is a rhombus by the definition of a rhombus. A rhombus is a parallelogram with 4 congruent sides. So, kind of an involved proof, but I hope you were able to follow along. And I'll leave the other half of the proof as an exercise for you to practice your proof skills. So let's move on to the next property.